Welcome to finding the F-score and the p-value for one-way ANOVA. So again, we're looking at the same example we've looked at in other Module 26 videos. So a university wished to compare the study skill levels of the different years on campus. A researcher randomly selected 10 students entering their first year, 10 students entering their second year, and 10 students entering their third year. The researcher had all of the selected students take a study skills test, which was scored out of 100. The researcher then compared performance by year. The data is recorded below. Can we conclude at the 5% significance level that not all 3 years have the same average performance? So I have the data recorded here. I'm not going to read it all off. To find or to hear the data read off, watch the intro to One-Way ANOVA video. So we have the box plots for the data. This is first year, second year, third year, and then all together down at the bottom. And again, we're looking to see how different the means are, or if the means are different or all the same, basically. So the mean for third year is probably somewhere around 80. The mean for second year is probably somewhere in the upper 70s. And the mean for third year is likely somewhere in the low 70s. And then altogether, the mean looks to be somewhere in sort of the mid 70s. I haven't taken the actual values here. I'm just sort of guessing where the means would be. So in this set, there's a lot of overlap. The means, based off of sort of how wide the box plots are, the means don't actually look very far. So in our example, the sample means are different. But with all of the overlap, in typical regions or in typical intervals, this could easily happen with the means all being the same. So even if the means were the same. On the other hand, let's draw a very similar box plots just underneath them. So what if this top box plot were more like this? And then our box plot below was much smaller as well. And then let's do a box plot for blue. One moment, the image is not showing. Okay, so I was drawing little mini box plots that should have basically the same mean or similar mean to sample means that we have, but they're much narrower. They're not as wide of box plots. So let's go ahead and do a box plot for our first year. And then a box plot for altogether. So if we look at these mini box plots, the means are the same as the means from the original box plots, but now there's much less overlap from our data sets. And it would make us think that it looks like first year and third year at least are completely distinct and probably do have different means. So, oops. Again, so with the narrower box plots, the sample means are the same. But there is much less overlap. So with the less overlap, then this makes it seem more likely that the means are actually different. So it's much more likely the population means are different. Or at least are not all the same. So somehow when we go to measure sort of how different the sample means are and how likely that means the population means are, we need to incorporate both sort of the variety or variation in the sample means, as well as sort of how spread out each individual data set or each individual sample was. So when we go to study the likelihood of sort of the population means being different, the F-score should incorporate both. Let me give myself more room. So the F-score should incorporate both the variation within the sample means or between the sample means, and the variation within each sample. So essentially what we do is the F-score is just the variation in the sample means divided by the variation within the samples. I am not going to explicitly go into exactly how we measure each of these variations. Instead, we will let Desmos do all of those calculations for us. In order to do those calculations, we will need to know the sample size for each of our samples, the sample mean and the sample standard deviation. So I'm going to go ahead and grab that information from Desmos. So if we go up to the link for our data, we can find the sample mean and sample standard deviation for both. So for all of them. So let's go to the mean of A and the mean of B and mean of C. And then let's do the sample standard deviation. So standard deviation of A, standard deviation of B, and standard deviation of C. So we need all of this information. So I'm just going to quickly take a screenshot of this and transfer it over. The way we want to record this information, the first year was A had a mean of 73. Second year had a mean of 78.3. And third year had a mean of 80.2. All of these were sample size 10. And then the standard deviations, we had 10.5, approximately 10.0 if we round, and then approximately 11.3 if we round. So all of this information is going to be needed for plugging in to Desmos to do these calculations for the F-score and the p-value. The way that we will plug these into Desmos is we will simply, for sample size, do 10, 10, 10. For sample mean, we will plug in 73, 78.3, 80.2. And for sample standard deviation, we will plug in 10.5, 10.0, 11.3. So this is how we are going to record the information in Desmos. So if we scroll down for calculating p-value, we will follow this link over to Desmos. So I have already plugged these numbers in. I actually did more decimal places than necessary. We can switch it to 10.5, 10.0, and 11.3 to match the notes. So plugging these numbers in, this is exactly how I had recorded the information in that table in our notes. Then what we have here is our F-score and our p-value. They have been found for us. The calculations are sort of buried here. They're rather complicated. So I certainly do not expect you to be calculating these by hand by any means. But the p-value and the f-score are just right there in the image for us. So I'm going to go ahead and transfer this over to our notes, and then I can make comments on it. So again, oops. If we look, this right here is our first year students. Then we have second year and third year. So this is first year, second year, and third year. So that does match precisely how I recorded the information here. First year, second year, third year, right? Then we have our p-value and our f-score just right in the image. So we have that our f-score is about 1.24 approximately, and our p-value is about 0.306 we'll go with. So this is our f-score and p-value, letting Desmos do most of the work for us. In the next video, we will talk about how we interpret the p-value for one-way ANOVA.